All right, so in the last section, we talked about segment lengths within a circle, and now we're going to be talking about angle measures within circles. So this is an angle we've talked about. What is the name of an angle like that? All right, so that's a central angle. And whatever degrees that central angle is also matches what? Yeah, the same arc that it's open to, right? Okay, so we're going to be talking about something called inscribed angles. Okay, these are all inscribed angles because the angle vertex stretches all the way to the back of the circle. So notice all of these angles have their corner right on the circle. So it gets pulled all the way back, kind of like a bow and arrow, to the back of the circle. Now notice all of these angles. I'll highlight one of them. Every single angle on this circle, they're all open up to the same arc, right? If you look at all of them, they all open up to this arc AB right here. So since they're all open to the same arc, all of the angles would also have to be equal because they're open up to the same curve right here. Okay, so if you have multiple arcs, let me draw a picture here with different colored angles so it's a little bit easier to see. If you had this angle right here and you had another angle that was open up to the same arc right here, then we know that those two angles would have to have the same measure. So these two angles would be the same degrees. Questions on that? It's a little bit easier to see when the angles are two different colors. All right. So let's use that idea on this picture right here. So they've given us a little bit of information here. This central angle right here is 102. Okay, so what is the measure of this arc right here? Also 102. Now the two angles, angle D and E, are both open up to that same 102. Would you agree? Okay, they're both like eating the 102. Now when you pull an angle all the way to the back of the circle, it shrinks the angle. Would you agree that this angle doesn't look like it's 102 degrees anymore? And neither does this one. We know that D and E are going to be equal to each other. That's what we just talked about. But they're not going to be 102 degrees anymore. It shrinks that angle. And it always shrinks the angle. The measure of angle D is going to be 1/2 of whatever that central angle is. Or you could think of it as half of the arc. So what are angle D and angle E? Yeah, they're both 51. So let's do just a picture right here and draw an inscribed angle. And let's say I told you that this arc was 120 degrees. How big is the angle that it's open up to? Yep, it's going to be half of that. So it would be a 60-degree angle. So that relationship will always happen. If an angle is pulled all the way to the back of the circle, it's half of whatever its arc is. Questions on that? All right, so let's talk about this. If this is the diameter, let's draw the center on here so we know it's actually cutting through here. What is the measure of this arc right here? Okay, so we got a 180-degree arc. What did we just learn about inscribed angles? It's half of the arc. So then we know this has to be 90 degrees. So anytime you have an angle that fits exactly inside of a semicircle, you know it has to be a right angle because of that rule. Okay, here's another property that always works. If you have a quadrilateral that fits exactly inside of a circle, okay, it's inscribed inside of it, the opposite angles are going to be what? What does it say? Opposite angles of a quadrilateral inscribed in a circle are, what does that stand for? Supplementary, so they equal 180. Okay, so we would be able to say that angle R plus what other angle? Yep, that's the opposite one. That would have to equal 180, and same goes for S and U. So they're probably going to put some algebra in there in your homework and on the test, like a 3x plus 5 and a 2x. So you would add those together and they would equal 180. Okay. Don't do the ones next to each other, the ones always across from each other. So we can write that down. This is how you would set up this problem. Plus 2x equals 180. We're not going to go through and solve that. You guys are good at that part, but this is the new property that we're going to be using. So if you have a four-sided figure exactly inside of a circle, the ones across from each other will always equal 180. Questions? Okay, so let's try that. Looking at this one, what are the two equations we would set up? Okay, what's the other one? Okay, so we'll quickly go through these. What's x going to equal? 20. Good. What's y? Good. Questions on that? Just make sure you do the opposite ones. Most common mistake on those is kids will do the angles that are next to each other. Try one more. This would be a very good example of what you might see on the test. What do we know about this picture that we could label from what we learned just today? Yeah. So we needed to double 38. So what is that? 76. Okay, so the arc is 76. What other clues did they give us? They do have the center. So what does this mean? BC is the diameter. Why is that really good information? We want to find this, right? Well, how would we easily find that? What would you put in the calculator or in your brain? 180 minus 76. And we get how much? 104. Good. Okay, so that's the answer. Any questions?